Hello, my name is Sam. I am an online maths tutor, and this is a video all about algebraic fractions in the GCSE syllabus. So, algebraic fractions are a nice little topic that kind of build upon the idea on factorising quadratics. So, you've got to be really good at your factorising in order to really ace this topic. But there are lots of marks available here in the exam, and it is a very good topic. So let's get straight into this. The question here is simplify fully, and it says x squared plus 5x over x squared plus 7x plus 10. Now, currently there is no easy way that we can simplify this fraction. There is nothing that on the top we can just straight up cancel with on something on the bottom. Instead, we need to create some factors on the top and on the bottom, which will divide with each other to simplify our fraction. So this is going to require factorising the top and bottom of the fraction, so let's do that. So on the top here, I can pull an x out of both of these terms and get x plus 5, and on the bottom here, this is a nice little type 1 quadratic, that's from my other videos, where you're looking for two numbers that add to make 7 and multiply to make 10. That can be 5 and 2. So this factorises to x plus 5 and x plus 2. We can then write that in here in our fraction. And since we have two numbers multiplied on the top and two numbers multiplied on the bottom, this x plus 5 will cancel with this x plus 5. And instead we will be left with x over x plus 2. You can imagine that as kind of saying, okay, well I'm taking x and multiplying it by x plus 5 and I'm then dividing it by x plus 5. So it doesn't really do anything, only the x plus 2 actually has an effect. So you can cancel the x plus 5 from both sides. Okay, that was a nice and quick example. Let's move on to the next one. So this one looks slightly trickier. Our coefficient of x squared is not 1, and that's going to slightly complicate things, but still it shouldn't be too bad. So we're going to start by writing out our fraction. And then we're going to factorise the top and the bottom to see if there's anything that we can do. Firstly though, there is nothing that we can do to straight up cancel. There's two x's on the top here, but then there's only one x on the bottom. There's a 3 and a 9 here, but there's a 1 and a minus 9 here, so there's no divisions which we can do straight away. So at the top I can put out a 3x, as this will multiply with the x plus 3. 3x times x is 3x squared, and 3x times by positive 3 is 9x. And that's going to be all over the factorisation for the bottom. Now this is a difference of two squares, x squared minus 9. There is no x term in the middle. This is a squared term, the x squared, and this is a squared term, which means that we can simplify this to x plus 9 and x minus 9. Since when this is expanded, you've got an x times a minus 9, and you've got an x times by a positive 9, and they will cancel. Sorry, that's not going to be 9, that's going to be 3. This is the square root of the number which is in the original equations. This is x plus 3, x minus 3, because then you get the positive 3 times by the minus 3 is going to be minus 9. So x plus 3, x minus 3. These x plus 3's will cancel, and you will get 3x, let's bracket that, over x minus 3. And then there's nothing else we can do to this. There's an x term on the bottom, but it's only multiplied by this 1, and there's a 3 on the top, and there's a 3 on the bottom, but this is a 1x, not a 3x. So this will be our final answer, and that is fully factorised. Well, fully simplified, as it is a fraction. Next up is what looks to be a much harder question. Now, I was doing this with a student recently, and it really it scared them at first, but after doing it for just a little bit, you really start to get the hang of what's going on, and it's much simpler than it looks. So, we've got 2x minus 2 over x plus 5 divided by x squared minus 4x plus 3 all over 2x squared plus 13, x plus 5, 15. Now we're going to use something here, as this is a division sign. We can actually change this to a multiplication sign and flip this fraction. So this is KCF, Some people like to say this is KFC, is a nice way to remember it, but it is the wrong way around. And it is keep, change, flip. I'm sure you know that from earlier on in the school. So we can keep this fraction the same, we can change this to a multiplication sign, and we can flip this fraction upside down. So 2x minus 2 over x plus 5 times by 2x squared plus 13x plus 15 all over x squared minus 4x plus 3. Now that these are multiplied together, we can put them in brackets. So we can have a 2x minus a 2 and a 2x squared plus 13x plus 15 all over x plus 5 x squared minus 4x plus 3. It looks slightly nicer than it did before. Granted, it is still quite long, but yes, there's less going on than there was previously. So we can do our simplifying again. So this 2x minus 2 is already pretty simplified. You could pull a 2 out of here, but we'll only do that in the future if we need to. So we'll start with the 2x squared plus 13x plus 15. So 2x squared plus 13x plus 15. We're going to look for two numbers which add to make 13 and multiply to get the 2 times the 15, which is 30. You can think about those two numbers for a second. But they are going to be 10 and 3, as 10 plus 3 is 13, and 10 times 3 is 30. Now our method for doing this is going to be 2x squared plus 10x plus 3x plus 15. If you're confused on that method, have a look at my video on factorising quadratics. I cover one of these. We can then split this down the middle, and we are going to pull out a 2x, x plus 5, plus 3, x plus 5. We can then factorise an x plus 5 out of both of these terms, and then the 2x plus 3 is what is left. So that is what's going to go on top. We're just going to replace our 2x squared plus 13x plus 15. Let's also factorise this x squared minus 4x plus 3. So again, we're going to look for two numbers which are going to add to make minus 4 and multiply to make 3. That's going to be minus 3 and minus 1. Just gave you a set there to think about it. X minus 3, x minus 1. And so we're going to replace this bottom bracket with x minus 3, x minus 1, and the top bracket with x plus 5, 2x plus 3. And so this becomes 2x minus 2. Then we'll factorise in this expression here. So x plus 5, 2x plus 3, and that's going to be all over the x plus 5 times by this one here. So x minus 3 and x minus 1. Perfect. Now we can see what cancels. So straight away I can see this x plus 5 is going to cancel with this x plus 5, and I'm going to factorise out the 2 as well from this first expression. So that's 2 times x minus 1 times by 2x plus 3 all over x minus 3, x minus 1, and then again this x minus 1 is going to cancel with this x minus 1, giving us 2 times by 2x plus 3 all over x minus 3, and that's going to be your final answer. So let's move on to the final question. So this one looks a little bit different. We don't have a fraction to start with. Instead we have some ratios. So this is going to be a little bit different. We have 2x plus 1 to x plus 2 is equal to x plus 8 to 3x minus 4. Now the fact the introduction of ratios here does make it look a little bit more complicated, but actually it doesn't make things too bad, since a fraction is the same as a ratio in a way. So 2x plus 1 to x plus 2 can be written as 2x plus 1 over x plus 2. And this is going to equal x plus 8 over 3x minus 4. And now this looks very similar to the ones we had previously. And so we're going to do some multiplication to get rid of these denominators and try and give ourselves a fraction. So I'm going to multiply both sides by 3x minus 4. And that's going to be all over x plus 2. And that's going to equal x plus 8. I can then divide by x plus 8 to get 2x plus 1 times by 3x minus 4 all over x plus 2, x plus 8 is going to equal 0. Now what we notice here is that this has nothing that can cancel with each other. So factorising, simplifying this fraction isn't going to work. Sometimes this is the case that you just don't get anything that's going to cancel, and so we're going to have to do this in a weird kind of way with quadratics. So if we go back up to where we started here, and we multiply it up by the 3x plus 4, but this time we're going to multiply up by the x plus 2. This time we're going to multiply up by the x plus 2, and we're going to get a different equation. So 2x plus 1 times by 3x minus 4 equals x plus 8. That doesn't really look like an 8, times by x plus 2. And now we can solve this like a quadratic question. So we can expand this to get 6x squared minus 8x plus 3x minus 4 is going to equal x squared plus 2x plus 8x plus 16. So we then want to get all of our x squareds on one side, all of our x's on one side, and all of our normal numbers on one side. First I'm just going to simplify and collect these x terms. So 6x squared, the minus 8x plus the 3x becomes minus 5x. Is that minus 8x? Yes. And then we've got a minus 4. This is going to equal x squared. The 8 plus the 2 is 10x plus 16. And I'm going to subtract x squared from both sides to get 5x squared. I can subtract the 10x as well to get minus 15x. And I can subtract the 16 to get minus 20. And that's going to equal 0. And now we have an equation. This is really good because we want to find the possible values of x in the question. This isn't a simplifying, it is a solving question. So what can I do to this? Well, I could do 5 times minus 20, find two numbers that add to get minus 15 and multiply to get that number. But instead, I can factorise a 5 out of this whole thing straight away. That's not going to be a 15. I factorise a 5 and simplify this to x squared minus 3x minus 4 is equal to 0. I can divide by the 5, and now this is a much easier question. Two numbers that add to make minus 3 and multiply to make minus 4. It's going to be minus 4 and 1, so x minus 4, x plus 1, and so our solution could be x equals 4, x equals minus 1. Okay, I hope that was helpful. It's a really good topic. It's a really good way to show off your quadratics knowledge. If you were confused by any of the stuff used in this video, anything related to quadratics, then please do have a look at my other videos, as I've made a series on quadratics. Yes, thank you for watching.